Okay everyone, we're on to two-step equations now. We did one step last time. Just take another little step today and get two-step equations. So the only new thing I really need to teach you is about the correct order to solve equations. And basically what you're doing is you're like undoing a math equation in a sense. I can get into that more in class. So because you're undoing it, you're going to do it the opposite order than usual. You're going to use SAMDEB, or the opposite of BEDMAS. You know that the normal order we do math is BEDMAS. You're going to do it backwards. SAMDEB is when it's backwards. So basically for today, the main thing you need to remember is look for adding or subtracting steps before multiplying and dividing. Right? That's not normal when you do math regularly. If you're evaluating something, you multiply, divide before you add, subtract in BEDMAS. But in SAMDEB, when you solve equations, you add, subtract first. All right, let's get into this. Same rules as before, right? The goal is to isolate the variable. You want to get this m all by itself. So this time, the reason we have two steps is we have two problem numbers. This 5 is a problem, and this 2, this minus 2, is also a problem. So which one should we get rid of first? Well, remember, we're going to look for adding or subtracting steps first. Which one of those numbers can be eliminated by adding or subtracting? The minus 2, the take away 2. Remember to always do the opposite operation. So because it's minus 2, we're going to add 2. And our final reminder, what you do to one side, you do to the other. Now don't put it here. That's not the other side. That's the same side. You just added 4 to this side and nothing to the other side. That's wrong. If you're going to add 2 to this side, add 2 to the other side of the equal sign. And there you go. So this minus 2 plus 2, that's gone. What's left on this side? You still have 5m. So it's not perfect. We want to get that m by itself, but at least we've simplified it. And on the other side, we have 18 plus 2, which is 20. Okay, we still have to get rid of this 5 here. What's that 5 doing to the m? It's 5 times m. So we do the opposite. We divide by 5. Divide by exactly the same thing so that you can eliminate it. Because 5 divided by 5 is 1, and we're left with 1m. But just like last time, if we have 1m, then really we just have m, don't we? So we're good. We've isolated the variable. M equals 20 divided by 5 is 4. So we're finished. Not sure if you got it right? Same rules apply. You can plug that 4 right in there. That's 5, 4, which means 5 times 4, and that's 20. Take away 2. 20 take away 2 is 18. We got it. Definitely got it right. All right, so the next one. We want to get the n by itself. We have a problem here with the negative 3 and a problem here with the plus 6. Which one of those things can we eliminate by adding or subtracting? The plus 6. We can get rid of it by minusing 6. What we do to one side, do to the other. So the plus 6 and the minus 6 are gone. We're left with negative 3n on this side. On the other side, we have, negative 12 take away 6. I don't like subtracting when I have integers, so what I'm going to do is add the opposite. Now I can do this. I have two negatives, and when you add, the same sign means it stays the same, so it's still going to be negative, and we add together the 12 and the 6, so 18. Okay, we still need to isolate the n. It's not isolated yet. What do we have to get rid of now? The negative 3. So that negative 3 is multiplying by n. We're going to do the opposite of multiplying. We're going to divide. And remember, you're not dividing by 3. That doesn't eliminate anything. You need to divide by negative 3 so you can actually eliminate this whole thing. What you do to one side, do to the other side. So this worked out nicely. The negative 3's are gone, so you're left with n. Nice isolated variable there. On the other side, you have a negative divided by a negative, which is positive, and 18 divided by 3 is 6. So we're good. Okay, variables on the right-hand side this time. Who cares? No different. Got to get rid of the negative 2. Got to get rid of the plus 30. Look for adding or subtracting first. Well, since this is plus 30, we can minus 30. What I do to one side, I do to the other. That's way over here. So if we look at the right side first, the 30's are gone, so we're left with negative 2m. And on this side, you have 20 take away 30. So you can probably do that without switching it. It's just negative 10. Of course, if we want to switch it, 20 take away 30, you can add the opposite. You end up with more negatives than positives, so you know your answer is negative. How many more is 30 than 20? 10 more. You'd subtract 30 minus 20 and get the 10. Anyway, you should be getting the integers by now. So we still need to get this m by itself. We got to get rid of the negative 2. That negative 2 is multiplying by the m, so we're going to divide by negative 2, the exact same thing, so we can eliminate it. And what you do to one side, you do to the other. Negative 2's cross out, so you're left with m equals negative 10 divided by negative 2. Two negatives make a positive. 10 divided by 2 is 5. It's totally okay to write it this way. If you're more comfortable, you can also write it that way. Okay, this one is very tricky, believe it or not, so watch carefully. You are trying to get rid of this number here, right? The 6. So it looks like this might be a one-step problem. All you have to do is get rid of that 6. Now, one mistake people think is that this is minus 6 and they're going to add 6. But this isn't. If you look at the sign in front, well, I don't see a sign in front, which means this is positive 6. How do you get rid of positive 6? You have to subtract 6. So you're going to do that to both sides. Okay, let's start on the left here. We have negative 4, and then we have to take away 6. So I'm going to add the opposite, and we have both of them being negative, which means our answer is going to be negative. And when the signs are the same, we add the 4 and 6, so we get 10. Now be very careful. This is not the answer, because do you see what's still left on the right-hand side? Yes, the 6 and the negative 6, those are crossed out. There's still this minus w, or negative w. So how do we deal with that? Well, some people can just figure this out. They say, well, if negative w is negative 10, then w must be positive 10. But I also find a lot of people get confused by that. So here's the other thing you could do. Which coefficient could I put right in this space right here? What could go there if it's just negative w? I could make it negative 1w. And now you could solve this the same way you've done before. This is negative 1 times w. So you have to do the opposite of times. You have to divide. What do you divide by? You divide by this exact thing, the negative 1, so that it will eliminate itself, the negative 1. What you do to one side, do to the other. So the negative 1's are gone and you're left with w. Perfect. And on this side, negative divided by negative is positive, and 10 divided by 1 is 10. So that is the answer there. That minus sign right there, right here, that gives people a lot of troubles. Don't lose it when you do that first step. And also, don't add 6 as your first step. That minus sign is after the 6. You have to look in front of the 6. There's an invisible positive sign, and that's why you subtracted. All right, on to the next side. Okay, looks a little different, but you should be able to figure this out. We want to get rid of the 6. We want to get rid of the negative 2. Which one requires an addition or subtraction step? The minus 2. So we do the opposite. We add 2 and we add 2. That gets rid of the 2's, but we still have this z over 6, or z divided by 6. And on the other side, 4 plus 2 is 6. Now, as I just said, this z over 6 means z divided by 6. We're going to do the opposite and multiply by 6. And multiply by 6 on this side. So the 6's cancel. Again, I know I probably haven't written it in the best place. I should probably write it up here, and it's more obvious they cancel. But I'm going to write it down here for now. 6's cancel, and you're left with z, which is perfect, isolated variable. And on the other side, you have 6 times 6, which is 36. Okay, you want the y by itself. You got to get rid of this, got to get rid of this. Which one can you add or subtract to get rid of? The negative 5. What are you going to do? Add 5 to both sides. So on this side, negative 8 plus positive 5. Do you have more negatives or positives? Negative. How many more you got? 3. Equals. 5's are gone, the negative 5 and the plus 5. And you're left with y over 7. Okay, that means y divided by 7. We still need to get rid of this 7 here. Since it's divided by 7, we're going to do the opposite. We're going to multiply by 7. Do the same to the other side. Negative 3 times 7, that's only one negative, so it's negative. 3 times 7 is 21. 7's cancel out. Y is left on this side. You're good. All right, we're rolling along here. Next one, we want the m by itself. Got to get rid of this and this. Which one of those things can be eliminated by adding or subtracting? That'd be the negative 2. So we're going to add 2 and add 2. So that leaves us with 3/5 m. 2's are gone. And on the other side, 1 plus 2 is 3. Now, remember this from last day? It's a bit of a drag, this one. This is 3/5 times m. And we want to get rid of the 3/5, so we need to divide by 3/5, and divide by 3/5. So when we divide by 3/5, 3/5 divided by 3/5, anything divided by itself is 1, so we get 1m, or just m, so that's perfect. And then we have to go 3 divided by 3/5. How do we do that? Well, let's make this a fraction, so 3 over 1. And the way we divide is we keep the first fraction the same, we change our division to multiplication, and we write the reciprocal. We flip it, 5 over 3. But before we multiply, we can actually ninja slice too, can't we? Divide these both by 3 and you get 1 and 1. So you end up with 1 times 5 is 5, 1 times 1 is 1, 5 over 1 is the same as 5. So there's your answer right there. Okay, now some ones that upset people, but there's nothing different. Just follow the same rules here. What do you need to get rid of? We got to get rid of this -4 and we got to get rid of this -8. Which one of them can we get rid of by adding or subtracting? The -8. So we're going to add 8 and add 8. So what's left? We still have -4n on this side. The 8's are gone. And 7 plus 8 is 15. This is -4 times n. I have to do the opposite operation, which is division. And I'm going to divide by what? By -4. What I do to one side, I do to the other side. So the -4's cancel. You're just left with n. Perfect. We've isolated the variable. On this side, a positive divided by negative is negative, so we know the answer is negative. And 15 divided by 4 is, what? 15 over 4? That doesn't go in evenly. Oh, I must have done it wrong. I'm so upset. Mr. Wodge, what's going on? Don't worry about it. You can get non-whole numbers, non-integer numbers. It's fine. You could just put your answer as being, since you're doing 15 divided by 4, 15 over 4. There's your answer, -15 over 4. Or if you want, pull the calculator, divide 15 by 4. It's still going to be negative, and 15 divided by 4 is 3.75. You could also write as a mixed fraction, of course. How many times does 4 go into 15? 3 times. How much is left over? That got us up to 12, so we have 3 left over, and the denominator stays the same. And of course, it's still negative. So these are 3 different answers you could have. Doesn't matter which one you go with. I'll circle these two because these are my preference. But nothing wrong with this one as well. Okay, these ones look scary with the decimals and everything. Still the same rules. So we want to get this a by itself. Got to get rid of this. Got to get rid of this. Which one is an adding or subtracting step? The -1.68, we have to add 1.68. What we do to one side, we do to the other side. Now, I'm okay if you use calculators in this section, and I'm sure you probably will at this point. But I just want to show you, you don't need a calculator. You can do this. You're doing -3.6 plus, whoops, I forgot the plus, 1.68. Do you have more negatives or positives? You have more negatives. -3 is bigger than 1. Sorry, 3 is bigger than 1, so it's negative, you have more of. And since they're different signs, what would you actually do with these numbers? You'd actually subtract. You take the bigger amount, 3.6, and you'd subtract 1.68. Line up the decimals, put a 0 in the extra spot here, and then you could subtract. Got to borrow from the 6, this becomes 10, 10 minus 8 is 2. Got to borrow from the 3, this becomes 2. It's now 15 minus 6, which is 9. 2 minus 1 is 1. Decimal moves straight down, so it's now -1.92. Okay, still got to get that a by itself. You got to get rid of this 1.2. It's 1.2 times a, so we better divide by 1.2. What you do to one side, you do to the other. So a equals, because the 1.2's cancel. Look, we could do this by long division too. Negative divided by positive, so it's going to be negative, and we have to go 1.2 into this. But remember, we don't want the number out front to be a decimal. So let's move that decimal over one spot and get 12. And let's move this decimal over one spot and get 19.2. Decimal moves straight up. How many times does 12 go into 19? Once. 1 times 12 is 12. Subtract. 19 minus 12 is 7. Bring down the 2. How many times does 12 go into 72? 6 times. And it works out perfectly. So there's our answer, -1.6. Of course you can use a calculator, but, you know, just kind of remind you of the skills we've already learned in this class. All right, last question, and I kind of lied. It's a 3-step question. I said 2-step question was the title. We're doing a 3-step question. So we want this x by itself. We got to get rid of this and this. The first thing we do is look for a step where you subtract or add. Well, that'd be the 0.61, right? I'm going to subtract 0.61 and subtract 0.61. So on the right-hand side, the 0.61s cancel. I'm left with negative, don't forget that negative or you're going to get this wrong, x over 3. On this side, I have 3.2 and I'm subtracting 0.61. Again, you can use a calculator. Put a 0 to fill in the space, and away I go. Borrow from the 2, this becomes 10, you got 9. Borrow from the 3, this becomes 11. 11 minus 6 is 5. 2 minus 0 is 2. Decimal moves straight down. So our answer is 2.59 equals negative x over 3. Now, we still have to get rid of this negative sign and this 3. You can do this in either order you want, but I'm going to deal with the 3 first. This is divided by 3, so I'm going to multiply by 3 and multiply by 3. On the right-hand side, the 3's cancel, so you're just left with negative x. And on the left-hand side, what the heck, I can do this too. 2.59 times 3. 3 times 9 is 27. 3 times 5 is 15 plus 2 is 17. Carry the 1. 3 times 2 is 6 is 1. Oh, look at this. 777. And move the decimal over 2 spots. 1, 2. So I get 7.77. We're not done though, right? We want the x by itself, and it's not by itself here. So we want to get rid of this negative right here, don't we? So again, some people get this. If negative x equals 7.77, then x must equal negative 7.77. If you don't get it, what can you put in right here? Negative x is the same as negative 1x. Okay, now we're good to go. This is negative 1 times x, so we do the opposite. We divide by exactly the same thing so we can eliminate it. What you do to one side, you do to the other. So the negative 1's cancel, and we have x. 7.77 divided by negative 1, you only have one negative here, so your answer is going to be negative. And when you divide by 1, it just stays the same. Negative 7.77 is your answer. All right, a little bit harder. Make sure you get this down because they're going to keep getting harder and 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 harder.